Hello everyone, I'm back again to talk about reaction examples this time. So I'm just going to run through the ones that we did in class, and hopefully you'll be able to follow the process. So our first example right here, we'll just call example A. We've got silver nitrate adding to sodium chloride, and because these are both ionic, we're going to have a double displacement. So we're just going to switch these two, and we're going to get Na NO3, that, plus Ag, or silver, Cl. Now, you can't just leave it like this. You have to double check that the charges are neutral. So we have to look and see. So we've got Na as plus 1, and we've got nitrate, which is up here, as minus 1. So we go back here. This is plus 1 and minus 1. Of course, chemists like to do it in the opposite order. So got 1 plus and 1 minus. So that one's balanced, or neutral, so we're good. And let's just take a look. We've got silver is plus 1, and chlorine is minus 1. So that one's also balanced, or neutral. Okay, and then because we didn't have to add numbers down here, okay, that means that we must still have the same number of atoms of all the elements on both sides. So let's jump down here. Now for this example, we've got a non-metal, iodine, and a non-metal here, bromine. And so this will be a single displacement reaction, and we'll end up with the calcium on its own, and the calcium with the iodine now, and the bromine on its own. So this is still an ionic compound, and so we have to check and see what the respective charges are. So we'll go back over to our periodic table, and we get calcium's plus 2, and we've got iodine as minus 1. So this is 2 plus and 1 minus. So we're still going to require those two iodines down here to make this 2 times minus 1 is minus 2, and that's plus 2. So altogether, that is equal to 0. Okay, so all we really need here then is 2 here. Now be careful, because that bromine is something that forms a diatomic gas in nature. So we end up with a bromine 2 here. And you can see that the subscripts already match what's on the other side, so it's balanced and there's nothing left for us to do. Going over here, now we have a metal reacting with an ionic compound, so we have to double check that aluminum is more reactive than copper. And it turns out on the scale, aluminum is more reactive than copper, so the aluminum is going to take the place of the copper. If it was the other way around in the scale, then we would have no reaction happening here. So here we have, now the copper has been displaced, and we have aluminum nitrate, NO3, and we have to check the charges again. So aluminum, so going over to aluminum, we already had aluminum. Oh no, we didn't. We got plus 3 for aluminum. So let's go back. So we'll put 3 plus here. And we already had nitrate. Nitrate's minus 1. Okay, so now it looks like in order to make this, remembering that this is all together, this here equal to minus 3, we're going to need 3 of these. So be careful, because now the problem is that we need to balance this. And we've got 3 nitrates over here, but only 2 over here. So to make that balanced, we'll make 6 on both sides. So we'll put 2 here and 3 there. So that balances the nitrates, but now you can see we have 2 aluminums, so we need 2 aluminums over here. And on this side we have 3 coppers, so we need 3 coppers over here. And so that's a balanced equation for that reaction. Now in this case we have a synthesis reaction, so we have a lithium and nitrogen going together, and so we have lithium nitride. So if we go back to our periodic table, nitrogen minus 3, lithium plus 1. So we have 1 plus and 3 minus. And we just have to make sure that we have the right combination to make it neutral. So we just need 3 of those. So we don't need this stuff up top anymore. And now we just have to balance it. So I can balance a nitrogen. So we have 2 nitrogens on this side now. We have 2 nitrogens on that side. But we have 6 lithiums on this side because 2 times the 3. So we need 6 lithiums on that side as well. Now we have a decomposition reaction where we have the lead plus the oxygen. And that's all that happens here. Just double check that you have the diatomic gas and that the equation's balanced, which it is. Here we have another decomposition reaction, but in this case we have lithium plus oxygen. Now remembering that this has to be a diatomic gas because oxygen forms that way in nature. And on this side we have 2 oxygens on this side, but only 1 over there. So let's make that a 2. And now we have 4 lithiums, so we have to make 4 lithiums there. And so that's a few examples, hopefully covering a pretty good subset of what you're going to have to do. Don't forget that you're going to have to identify what type of reaction you have and come up with the products yourself. So that's a major difference between this and just regular balancing equation questions that we've done so far. So good luck with your practice.